Okay, welcome back to Programming with Slick2D. When we last left off, we had what do we have? We had a background and a UFO, which I can see right here. We drew a background and UFO. So you should have something similar to this, where I have my UFO right here, and then my background. Of course, you could have used any images that you wanted. Okay. Our goal today is to get this UFO to move. Now, I looked in the comments a little bit, and I saw people saying, "Oh, they want the UFO to shoot and do some fancier things." We're not quite ready to do that. We are going to get to it, but not in this episode. Okay, this will probably be. Well, I don't want to get into it yet. Okay, so we're going to get this UFO to move. All right, but in order to get this UFO to move, we've got to understand some things. So, what we need to understand. So, what we want to do is, get this UFO to move to the left, right, up, down, stuff like that, okay? But what we have to know is, which direction is left, which direction is right, which direction is down, and which direction is up. Okay, those are very important things to understand. So, if we look at these directions, if I look at to the right and to the left, it's the same as you get in math, okay? Same as you get in math. Sorry, I had to turn my TV off real quick. It's the same you get in math. So to the right and to the left, that's your positive x direction to the right. Just like it is in math, you move along the x-axis to the right, you get positive x's. You move to your left, you get negative x. Okay. Now, I'm not talking negative values. I'm talking like decreasing x values. All right. You should remember that there are no negative numbers on the screen. All right, and we'll talk about that. I'll hammer that home in a second too. All right, so as we move to the right, our x values get larger. Starting at 0, it will go 0, 1, 2, 3, 4, 5, 6, and it will keep going up higher when you move right. As you move left, x values decrease. All right, basic, right? Here's the number one problem with new game programmers when it comes to games, is the up direction is the minus y direction. The complete opposite that you learn in math, all right? And the down direction is the positive y direction. Again, the complete opposite that you learn in math. So as you move up the screen, the y values decrease. And as you move down the screen, the y values increase, okay? So if I want to move left, right, up, or down, it's very easy. If I want to move left, I subtract from the x value. If I want to move right, I add to the x value. If I want to move up, I subtract from the y value. If I want to move down, I add to the y value. How much do I subtract or add? That's all dependent upon how fast you want your graphic to move on the screen. Okay? So if we want to move in a diagonal, let's say we want something to move this direction right here. Well, which direction is that? Well, I got to move to the left, so that's negative x, and I got to move down, that's positive y. Now I'd have to subtract from the x and add to the y to get it to move this direction. Okay, so in conclusion, the x direction, simple, same as math. To the left, x's get smaller. To the right, x's get bigger. But the problem occurs with the purple y-axis right here. It's reversed. Up is negative y, and down is positive y. Okay? So, and here's what I was going to talk about. I want to remind you that that top right corner right there, that top right corner of your screen is 0.00. That kind of looks like an owl right there. But that's x0, y0. Okay? So that 0.00, that means as I move across this direction to the right, I get positive x's. Okay? As I move down from this point, I get positive y's. Okay? Now, as I move up, I have to subtract from y, and as I move left, I have to subtract from y. Okay? But keep in mind that point is 0, 0 right there. All right? Now, we're almost there. One of the most important things that we haven't talked about yet is, here's my game running. I took a little screenshot of the game running. In this top right corner, top right, did I say top right? Top left corner. In this top left corner, it says FPS 767. Okay? That stands for frames per second 767. What that means is my game is updating 767 times a second. That means this UFO is getting drawn 767 times a second. This background is getting drawn 767 times a second. That's a lot, okay? And this number will be different on everyone's computer. Okay, it'll be really similar on computers that are about the same build. Okay, so everyone who's bought a new computer will get about roughly the same FPS, but an older computer is going to get some very low FPS. All right, and we have to know this frames per second because it becomes very important. All right, and Slick2D gives me and you a variable called delta, which has to do with this frames per second, okay? And now, let me make a chart and explain this to you and why it's important. The frames per second, as the frames per second get higher, okay, the problem with the frames per second getting higher is that it's doing everything faster. That means everything starts moving faster as well, okay? Everything updates faster, everything moves faster. That means if you write a game and you move this UFO and you're happy with the speed, the UFO is moving perfectly, and then all of a sudden you put it on a fast computer, all of a sudden the UFO moves faster. Obviously, we can't have that because that means everyone's computer is going to be running the game at different speeds. So, as frames per second gets higher in your game, this variable delta gets smaller in exact proportion. So, if frames per second goes up, let's say 10%, delta goes down 10%. All right? So they're inversely proportional. They're exact opposites of each other. The higher frames per second is, the lower delta is. And the same thing is true. As frames per second dips and drops, okay, delta increases. All right? So they're inversely proportional. The higher frames per second, the lower the delta, and the lower the frames per second, the higher the delta. Okay? That's going to be very important. All right? So, here's the whole conclusion. Here's the piece of code. If I want to move my UFO to the left, so I want to move him to the left here, what I want to do is take his x value, wherever he's at x, and subtract from it speed. This is how you subtract from it. X minus equals speed. This equation will subtract speed from x, whatever speed is. Okay, we can make it 5, 10, 0.1. We can make it something really small. We can make it something really large. Whatever the speed is, x minus equals speed will subtract speed from the x value. Okay? Now, there's a problem with this. All right? You don't want to do it this way. And the reason you don't want to do it this way is it doesn't take into effect the frames per second. It has no frames per second, math at all. Okay? So if I look at this, let me take this line away. X minus equals speed. The problem with this is on fast computers, it's going to do this, let's say, 800 times. And on slow computers, it's going to do it 400 times a second. So on a fast computer, if it runs at 800 times per second, this happens 800. On your grandma's computer, she's still running Windows XP. It's going to run slow. It's going to run 400 times a second. That means it's going to be faster on the fast computer, slower on the slow computer, okay? Which you don't want. It's going to be unplayable. On a really fast computer, it's going to be too fast. No one's going to be able to play it. It's too fast. And on a slow computer, no one's going to want to play it because it's too stinking slow. All right? So let me cross that back out. We don't want to do that. Here's what we want to do. We want to do the same equation, x minus equals speed. That subtracts speed from x, but I'm going to multiply by delta. Now, what does delta do? Well, on a slow computer, delta gets higher. What's that going to do? Speed times delta. If I multiply by a higher value, delta is going to result in a higher speed. It's going to make up for that slow computer. As a really fast computer, a supercomputer, it's running 9,000 times a second. Okay, that supercomputer is going to force delta to become really small. And when I multiply speed by a really small value, it's going to result in a really small speed value. Okay, so now the really slow computer at your grandma's house and the supercomputer at NASA, they're both running the game at the same speed because they're both multiplying by this delta, and delta goes up for slow computers and down for fast computers, so I get the same thing. So I'm still moving to the left with this, and this is the way I want to do it. Okay? I hope I didn't lose you on that. That's really important to understand the role of this delta. Okay? Now, this delta, we don't have to worry about it. Slick2D takes care of it for us. Okay? So, let me go back to my code, and let's get this UFO moving. Okay? So, we're going to take this draw image UFO right here, and I'm drawing it right now at 200, 200. Okay? I don't want to draw it at 200, 200. I'm going to change that to X y. Now, it's going to underline in red. We have some errors, but let me explain what I just did. All right, I'm not going to go into Java in depth because I'm kind of assuming you know a little bit of Java here. But instead of putting 200, 200, I put x, y. These are variables, just like they are math. What is x equal to and what is y equal to? Well, nothing right now because they don't exist, okay? But they can change, just like variables in math. They change. That's the definition of what a variable is. So what I'm going to do is, instead of putting 200, 200, put x, y right here. Now, up top, right where I have UFO, I'm going to declare x to be a float. X equals, let's start it at 200, and float y equals 200. Now, what that does is, right before this, I had 200, 200. Now I have x, y. Well, what's x equal to? Well, look up here. X is equal to 200. So 200. Y, instead of y, I used to have 200. Well, I have y now. Well, what's y equal to? 200. So all I did was replace the 200, 200 with two variables and then set those variables each equal to 200. If I run now, okay, I get no change. My UFO is in the same exact spot. All right, so why did I do it? Why the heck would I do that? Well, because now I have the power to change x and y anytime I want. Okay, at any point I can change x and y. Okay, and you might be thinking what float is. Okay, float is a decimal number. Okay, so technically this is 200.0. Okay, and 0.0, and then a lot of times we append an f to the end of it to call it. This is the number 200.0 in float format. 200.0 in float format. All right, it just means it's a decimal. All right, I know it's confusing. Why didn't they call it decimal? Because they didn't. So we call them floats. Okay. Now I'm also going to create a float speed. How fast do I want my UFO to move? I'm going to start at 0.2 f. I don't know if that's going to be too fast or too slow. I won't really know until I run it. Okay, and I'm not even using the speed yet. So speed is 0.2 f. I'm just declaring it. Let's just call it 0.2 f, and we're calling the variable speed. All right, now, for the movement. If I look, I have, again, these three important methods. I got render. That's where I draw all my stuff. I got init. That's where I load all my stuff. And I got update. That's where I do all my game logic, AI, and user input. So here's exactly where I want to do user input. Now, if I look at this right here, these are the arguments to update. Eclipse by default just calls them arg0, arg1. All right, I'm going to change those to more meaningful names. Okay, instead of calling the game container arg0, I'm going to call it GC for game container, and instead of calling int the int arg1, I'm going to call it delta. So here's where that delta variable comes in. It's given to me by Slick. Okay, I don't have to worry about it. All right, so I'm going to rename those so that I have access to them. So I got game container GC and then int delta. All right, now what I'm going to do is I have to pull the keyboard for input. That means I have to ask Slick, basically what keys are being pressed. You know, what's going on? What keys are they pressing? Where's the mouse at? Are they pressing any mouse buttons? Slick keeps track of that for me, and here's how I get that. So I'm going to say input. Maybe I shouldn't call it. No, I'm going to do it. Okay. Input equals, gc.getInput. All right. Now, you have a little error on the first input. It's the first capital input. I'm going to hover over that first capital input and import it. Okay. Let me undo that. So that hover over it, and you're going to import from org.newdawn.slick. Okay. All right. So you import that. Now, what this line does, okay, is it gets. Let me see. I'm going to say asks Slick2D what keys are being pressed. It does more things, but for right now, we're going to say it asks Slick2D what keys are being pressed. So right now, Slick2D can tell me, hey, the A key is being pressed. Hey, the right arrow is being pressed, or the 5 keys being pressed. It can tell me exactly what's being pressed right now. How do I use that information? Well, I'm going to use the arrow keys for this one. So I'm going to say if. I'm going to say input dot is key down. Okay? And then I'm going to say capital input dot, and here's where I choose what key I want. Now I know that that was wrong. I know that it's going to be key underscore right for that key, for the right key. So this is saying if the right arrow is being pressed. All right. Now I know I'm a pretty fast typer, so if you need to, just keep pausing and coming back. But I really don't want to slow down because we're already at like 15, 16 minutes and we haven't even have a moving UFO yet. All right. So this is saying if input.isKeyDown, input key right. This is how I would say if the right arrow is being pressed. Okay. And it's always going to look like this for checking keys. You have if, you have input is key down, and then you have the key you want to check. Now here's the question that I hope you can get. Okay. If they hit the right key, what do I change? All right. If they hit the right key, what changes? All right. Pause the video. Think about that. Answer that question. No cheating. I don't want you cheating. Pause the video. Pause the video. Did you pause it? Okay, you paused it. All right, you're back. Okay, here we go. What should happen if they hit the right key? Okay. Well, remember that in my little animation here, that right is the positive x direction. Okay, so I want to add to the x. So x plus equals, that's how I add to x, speed. And like we said before, this is incorrect. Okay, you don't want to say plus equals speed because the last thing you want to do is multiply by delta. That way it keeps it on the same speed for every computer. What this says is if the right arrow key is being pressed, okay, I add to the x whatever speed is times delta. If I run this, what you should get is when you hit the right key, your UFO moves to the right. How fast does it move to the right? Well, it moves to the right at this speed right here, at 0.2f. If you want it to be faster, you know, I can make it double faster by changing that to 0.4, and now it moves really fast. Or I can slow it down. You know, I could significantly slow it down and go 0.05. And now I have a really slow-moving UFO. Okay, so I can control the speed right there, up top. I'm going to go back to 0.2 because I think that was pretty good. All right, that's my right. So I'm gonna select this entire if right here. I'm going to copy it. If you don't know how to copy, we're going to be doing lots of copying and pasting because it's always faster than typing. All right, a lot of people will highlight this, right-click, and go copy. Okay, but check out right here, Control-C is the shortcut for copy. And then if you look at paste, the shortcut is Control-V. So that's what I'll be doing. If you can't keep up with my copy and pasting, just pause. But I'm going to copy this whole if and paste the whole thing. All right. Now this is interesting right here. See that when I pasted it messed up like the format? This is important. Like you don't want to leave your code like this. It gets really unruly and hard to like mess with, okay? So I could go and pull this back and line it all up like it's supposed to be, okay? Or the shortcut in Eclipse is you can select all your code or just the code you want to change and click Control-I, okay? And that fixes your alignment right off the bat, okay? Now, to change this, I'm going to say I'm going to change this to left arrow is being pressed. I change this to the left arrow, and instead of this equation where I'm adding to the x value, what is the left direction? The left direction is the minus x direction. So it's x minus equals speed times delta. So if I run it now, I can move left and right, okay? Any way I want at 0.2 speed because that's what I have. Close it. I want to paste again and fix my indentation. Again, another thing, how do I select all real quick? Control-A for select all. Okay, so that's how I select all, Control-A. All right, now I'm going to say if the down arrow is being pressed, I change it from key right to key down. And this whole thing's going to change now because now down is in the y direction. But which y direction is it? Okay, well, y direction is minus, right? Down. No, wrong. Remember, it's reversed. Down is the positive direction in Y, okay, in respect to Y. So if they want to press down, I add to the Y speed times delta. And I'm not even going to test it. I know it works. I'm going to do my last one here, copy, paste. And this is going to be if my up arrow is being pressed, I change key right to key up. And again, up is going to be the minus Y direction. So when you're all said and done, you should have 4 of these ifs. 1 right here for the right direction, 1 for the left direction, 1 for the down direction, and 1 for the up direction. So when you run it, you should be able to move this UFO wherever you want on the screen. Nice, smooth movement, and it will move this way on every computer because you're multiplying by this variable delta, okay, which Slick keeps track for us, and it's a higher value on slow computers and a lower value on faster computers to neutralize the speed difference between all these different computers that are going to be running your program. All right. If you run your code and something weird happens, like you hit right and it moves left, or you hit down and it moves up, or like something really strange happens, okay, obviously your problem is going to be right in here, okay, with one of your equations, which is the wrong way, or you're adding or subtracting when you should be subtracting and adding, okay, or you have an X where there should be a Y, right, something like that. All right, we're over 20 minutes now, so I'm going to stop there. I know we haven't done quite much. We haven't done quite much yet. We haven't gone. I can't talk right now. We haven't done too much yet, but we do have a moving graphic on the screen, and we're getting there. Okay, so I think we'll start laying the groundwork next time for a game, like a full-fledged game. I can't do everything that we would do in that game, but we'll get some shooting in, and we'll make, I'm not sure what kind of game we're going to make yet together, but we'll make something. All right. 23 minutes or so. I'm sorry. I feel like I just blew through that, but there was so much to cover, and I don't want you listening to this for 45 minutes. I also don't want to be doing it for 45 minutes. But I hope you liked it. Hope you enjoyed it. Leave me a comment. Hit the like button, and get to programming, okay? I hope you enjoyed it. Hope you learned something, most of all. And if you have any questions, you can send me an email to mckelray@gmail.com. That was the wrong. Forget that. I'm going to put the link down there right now, okay? Because I don't want you learning how to spell it. All right? So mckelray@gmail, but I'll leave a link down there. So leave me a comment, drop me a line, send me an email if you need help with anything. And I'll see you next time. We'll get started on our first full-fledged game. All right? Peace. Thanks for listening. I'm Mickey Elray. As always, have a good day, good night, good year, good week, good whatever the heck you're doing. All right? Enjoy yourself. Enjoy life. I will see you later. Peace out.